Okay, and then our other problem here, two vertical poles, one 16 feet high and the other 24 feet high, stand 30 feet apart on a flat field. A worker wants to support both poles by running rope from the ground to the top of each post. If the worker wants to stake both ropes in the ground, at what point would the stake be placed to use the least amount of rope? So the first thing we have here is what's going on. So we have two poles. One that's 16 feet tall, and the other is 24 feet tall. They are 30 feet apart. And we want some stake in the ground where we could attach a rope to the top of the pole to the stake. And there's one rope between those two, and it is the least amount of rope possible. So where this point is, we're not quite sure. So what we want to find is the length of this rope altogether. Well, what we have here are right triangles. So we're going to be looking at some Pythagorean theorem in order to kind of help us out. So one of the things that we have to decide is what we want to make x. What we're going to make x here is I'm going to make the distance between the shorter pole and the stake x. So this is going to be x. This means this distance over here is going to be 30 minus x. So in order to find these two distances, I need to do the Pythagorean theorem twice. So I'm going to label this one as C1, this one as C2. So we have a squared plus b squared equals c squared. So I have 16 squared plus x squared is equal to c1 squared. If we want to get c1 by itself, which is what we want, we are going to take the square root of all of that. And then we're going to do it again. But this time we have 30 minus x squared plus 24 squared equals c2 squared. We're going to do the same thing, take the square root of 30 minus x squared plus 24 squared. The rope is the total length between these two, so our equation for the length of the rope is going to be the square root of 16 squared plus x squared plus 30 minus x squared plus 24 squared. We need to take the derivative of this and set this equal to 0. So we are going to change what this looks like. Instead of writing a square root, I'm going to put it to the 1/2 power. And we are going to take the derivative of it. So we have 1/2 times the inside, take away 1, 1/2 times the inside times the derivative of the inside. 16 squared is a constant, so it's 0, and x squared's derivative is 2x. And then we're going to add the derivative of the other one. So 1/2 times the inside having some little hiccups in my brain today. And then we're going to take the derivative of the inside. In the inside, I have chain rule again. The derivative of 30x squared, we're going to have a 2 times 30 minus x times -1. And the derivative of 24 squared is just 24. So this is what we need to simplify now. So we're going to do some cleaning up a little bit. We have a 1/2 times 2x is going to leave us with x. The negative in the exponent tells me we have division. The 1/2 tells me we have a square root. So I have x divided by the square root of 16 squared plus x squared. And then we are going to kind of fix this a little bit. Things that I see here, we have times a negative. Nothing else is being multiplied by a negative, so I know I'm going to be now subtracting. We also have a 1/2 and a negative, so I have a fraction. In the denominator is everything inside those parentheses, and it's inside of a square root because it's to the 1/2 power. And then if I look at what I have a times 1/2 and a times 2, so those are going to make 1, so they will go away. And we have a 30 minus x, so I have a 30 minus x on top. So this is the equation that we are kind of dealing with. I could try to make a common denominator by multiplying each one by the other square root. This is going to get a little bit unfortunate. So what we're going to do instead is we are going to use a graph in order to kind of help us out. So we're going to use a graphing utility to graph the derivative, and then we'll kind of evaluate that. So we're going to take this and we're going to plug it into Desmos. So we want to put in this function. So I have x divided by the square root of 16 squared 16 squared plus x squared. Let's get all of that in the square root minus 30 minus x divided by the square root of 30 minus x squared plus 24 squared. So when I look at this, here is what my graph is going to look like. It's very shallow, so I'm going to change the window. The x-axis is fine, but the y-axis, we're going to change it to be kind of in the like -2 to 2 range. When we do that, we can kind of see that there is a spot here where it's going to be below the x-axis, above the x-axis, and then it's going to kind of flatten out on both sides. And what we want is, we know this is the derivative, so we want to set this derivative equal to 0. So I want the equation y equals 0 here. So that way we can kind of see where they intersect. So if I look here and use Desmos, I can see that they intersect at x equals 12. And this is going to be our important point. This is our critical value. And then we have our graph here. So if we think about what we have here, our function is decreasing. and then increasing. So I know that if we were decreasing, we're going downwards first and then going upwards. So I know that this is going to be a minimum. So r prime equals 0 when x is equal to 12, and we used a graphing calculator. And then we also use that to kind of tell that it is a minimum. So what I know is the amount of rope needed will be minimized when so we're trying to figure out where the stake should be placed. So when the stake is 12 feet from the 16-foot pole. If we did it the other way, so the longer pole's distance to the stake was x, we might get a slightly different value, but we would be doing the exact same things. This is a problem that I really wouldn't expect you to not have access to a calculator on. We wouldn't ask you a non-calculator question where it wouldn't be possible.